Welcome everyone to the first ever STEM Symposium at ATIC, the Advanced Technology and Innovation Centre in Rockhampton. I'd like to start by acknowledging the traditional owners of the lands on which we are meeting and pay respects to elders past, present and emerging.
We meet on this country in the spirit of reconciliation. As we come together today, we acknowledge the rich history of this land and offer recognition and respect for the custodians who have lived here continuously for many centuries. We acknowledge elders of the past who have created the history, those who are with us in the present to lead us forward, and the elders and leaders who will guide us in the future. For all embody the memories, traditions and cultures that are vital to preserving connections to this land. We acknowledge and offer greetings to First Nations people from everywhere in Australia, to those on country bounded by sea, to those from the Red Interior, to those who dwell amongst magnificent forests, and to the many who live in cities across this land. Central Queensland University, Australia, acknowledges the significance and strength of Aboriginal and Torres Strait Island cultures and their place in the expression of an inclusive national society. Thank you for coming together today on Country.
Thank you. Now, we have a series of short, sharp presentations from a variety of people across our footprint. So we will head to Simon, if you are ready. Simon Cumming is doing a wind generator activity that he does with CQUniversity and high school students. So over to you, Simon, in the labs over on Rockhampton campus.
Hey, how are you going? How's everybody? It's strange, I feel a bit nervous. Normally I have no problem speaking in front of people. But anyway, it is what it is. Can everyone see me? I think my head's just a little bit chopped off. Yeah, so I decided to stay in the lab for this one because I've got an engagement session actually on today. And hopefully you can see in the background the setup that I have for this. Someone keep an eye on the timer, let me know when it's on 4 minutes. Should have asked beforehand. So basically we've got our wind source, which is just a fan because it's an indoor activity. And we've got a couple of items. What you can't see is a pile of cardboard. So I find that just regular box cardboard is perfect for this activity. And I should mention Aruna, who's our head of school. The titles change all the time, but he basically had this idea of doing this wind generator, one of our electrical academics, and so that's why we've got what we have now. But we've been doing engagement activities for years and years and years. Just ask CQUniversity. Now, try and hold a few of these items up close to the camera so you can see them. So these little parts form the hub for the wind generator, and they're 3D printed. There is a little Lego attachment on the back because it plugs into a little Lego DC motor on this stand here. The other components which you didn't see before are these little sections which hold the wind blades onto the hub. Now the students assemble these, and what's important is they can adjust the angle of the blade as well. And that's part of the experience of trial and error and trying to get the best performance out of the wind generators. So what I've done here is I've just created a basic example, like that. So you can see all I've done is I've just cut some square blades. Now, these are terribly boring shapes. The students their just imagination just goes wild and they create some quite interesting designs. And they sort of bounce off each other with the ideas. It's quite an enjoyable engagement experience. I'll just kick it in. The last thing item I should show you is the little device that I built, which is for measuring the voltage that it generates. So you could just use a multimeter, which is a piece of lab equipment. My head's still being chopped off. But I thought I'd utilise my tech skills to make something a little bit more elegant. So this one displays voltage and power, and how much power something produces is pretty relevant. I'm looking up at the TV, by the way, which is why the angles are not quite right. Anyway, I'll just plug it in and I'll just show you a test drive. Demonstrate a test drive. Okay, now I'm going to move the camera just so you can see this. So it's just showing that this generator is producing 3.7 volts and 10 milliwatts of power. And it's designed to capture the maximum value, so it's relatively stable result. Now, of course, when there's just one person showing you this, it doesn't really capture the mood when you have a whole bunch of Year 10 students in there and they're joking around and they're being creative and some of them are competitive, some of them are artistic and they colour their blades. What you're missing in this presentation is the feeling of the high energy level. And it's such I'm probably a unique personality type to be in the lab tech area. I love that kind of thing. And I get a huge energy boost out of it. So, and also helps me skill up on dealing with little adults or younger adults. Edit, delete, rewrite, you know what I mean. So
1 minute.
Yep. Am I in 4 minutes? Yep. So that's basically what we do. Any questions? I think I was too quick then. I see 9:07 on the television.
No,
So,
I went quicker on my introduction. Thank you, Simon. Thank you for that. We will now cross back to ATIC Centre. Next, yep. Dr. Harik Strap, who will be showing you 3D printing to generate high-resolution models of viruses to introduce virology to CQ schools. So just bear with us while we get the PowerPoints up.
All right, can you hear me? So I normally do this as a pretty interactive thing, and I throw things at the audience, and I can't throw anything at you, unfortunately. But if you're available, I'd like to throw things at you. Would you like to catch the cold? Try. Excellent. Anybody else, would they like to catch the influenza virus? I also have the coronavirus available if somebody would like this. So what I've just thrown around is the most highest resolution you can print with a printer of a virus. That's courtesy of Simon Cummings and our expertise in 3D printing. So this is a crystal structure, and we've obviously blown it up to enormous. Are you ready to catch the influenza virus, please?
All right.
All right, great. Excellent. I'll leave them back again. Okay, so next slide, please. Right, can you see my slides? You go on to the next one. Right, so, I can't really see them either.
All right.
So there's
a lot of echo. I think someone's got their mic still on.
Sorry.
So everyone should have their mic off except for Porrick, please. Sorry to be so bossy.
No, it must sound horrible. Echo. How's that? Is that better? Okay. All right, I'll keep going then. All right. So first thing we want to understand is sometimes we get a variety of age groups. So particularly for the younger students, maybe years 8 to 9, really what we want to start off with is understanding that viruses are tiny. We can't see them. And what I show them is a picture of a microscope, which I think is in the next slide. Okay, so I tell them, you normally have the microscope which is on the left. You might have that in your school, and you might be able to see some simple things like blood cells or plant cells, etc. But to see a virus, we need an electron microscope, which is on the right, and that gives us those pictures which are on the furthest right. And it's from those pictures we can take measurements and actually print out high-resolution structures of the viruses. So if we go to the next one. So viruses then have a variety of structures on the outside, which we can show the students. And if you want to throw the blue bars back to me, or you can roll the orange one. All right, so as you can see, these viruses have got these little projections on the outside. They're tiny little knobs, okay? So what we want to get the students to understand that in biology, structure is function. Those tiny knobs have a function, okay? So what I'm showing you on the screen is that some viruses have knobs on the outside and some don't, okay? So the other virus, which you're going to throw out, is... This was crazy. All right, this is the common cold virus, and this is one that we get every year, but not so much this year, but it doesn't have knobs on the outside. But they all have the same function. They get inside our cells. So next slide, please. All right. So the last virus, obviously, is the one that we're in the midst of at the moment. This is the coronavirus, okay? But the coronavirus also has a series of knobs on the outside. I'm not going to throw this one.
We don't want coronavirus.
We don't want coronavirus. But I'm going to remind you about the spike-glycoprotein. It's the most important protein, I imagine, worldwide at the moment. That's the protein everybody's making a vaccine against to protect us against coronavirus. Okay. So in the presentation, we talk about how do we get viruses, particularly respiratory viruses, and they're spread by respiratory droplets, which have a defined size, and they can move around rooms, and they can exist in rooms. But we understand that at the very basics, we can stop that transmission by, go to the next slide, by social distancing and wearing masks. Okay? So we understand how far a virus can travel in terms of its respiratory droplet. So that rule that was introduced in terms of social distancing wasn't an arbitrary rule. It was based on science and understanding how far those respiratory droplets could last in them. So normally we have a nice video about transmission of influenza virus, but we'll move to the next slide. So viruses get inside our cells by using one of the little proteins on the outside, and it acts as a key. It essentially opens up the cell, and the virus enters the cell and uses our cell as a photocopying machine, so to speak, to make many, many copies of the virus. So if you go to the next slide. Some viruses can change every year, okay? An influenza virus is one example. This is a bit sharp. I don't think I'll throw this one.
No.
But this is the protein that's on the outside of the influenza virus. It's called hemagglutinin. It changes every year. So we need to get a vaccine every year to protect ourselves. So if you go to the next slide. So the biggest change to this protein was the Spanish flu pandemic. So that was the last pandemic prior to coronavirus that the world experienced. And it was due to a change in this protein. So when you get large changes in proteins of viruses, our immune system has no experience of that virus, that protein. And so we have widespread pandemic disease. So if we move on to the next slide. So the next topic that we like to talk about with students is how viruses, where do they come from? Okay, so with coronavirus, we know that the virus originated from bats and may have moved through into another animal called a pangolin before it came to us as humans. And on that virus journey, the virus mutates and adapts, and so it becomes quite pathogenic in our cells. So that's the example of how the virus in bats may have gone through what we call an intermediate animal in pangolins in a close association before it came to humans. So I'll finish up with the coronavirus because that's always the topical one for these talks. So the search is on to protect ourselves against coronavirus, and we're going to do that by making a vaccine against this protein, which is the spike-glycoprotein. And it's present on the outside, one of those little knobs that we're able to print at high resolution. So I'm going to focus on one vaccine approach, which is our own Australian approach at the University of Queensland. So if you go to the next slide. So they have a very, very simple, a very, very elegant approach. And the message I wanted to get across to high school students is that in biology, structure is function. Whilst the 3D printer builds and prints these beautiful structures of biological proteins in normal cellular life. Sometimes that structure doesn't work. So what UQ have done is that they're going to make the spike-like protein as an imagen for a vaccine, but they're going to add a molecular clamp. So I've got my own clamp here. So what they've designed in terms of a molecular approach is to clamp the protein, okay? Just like that, and that will maintain structure. So this will be a highly immunogenic protein, probably a very, very successful vaccine. So I think we'll leave it at that.
Thank you.
Right, thank you very much.
Thank you.
All right. If we've got time, I've got some pictures I can show from the 3D printing.
Oh, that'd be great.
Yes. Just, you know, like 30 seconds, it might be interesting.
You ready? Is he ready to go? Yep.
Yeah.
All right, I'll just share the screen. Okay, so this is just the software program that we use to print the viruses on one of the upbox printers. And you see, it's good because it shows you how long it takes to print a model. So this diameter of this print is 100 millimeters. Obviously, we don't have real viruses that big. I think we'd all be finished if that was true. 17 hours and 21 minutes. Very, very slow process. 3D printing. Oh God, I hope everyone can hear me. 3D printing is very slow. The material consumption is about 120 grams. Now you can buy a kilo of material nowadays for about $20 or $25. So that's like less than $5 worth of material to print it. The main thing is that the time it takes to print, and also the skills of the person driving the printer, which, not to sound immodest, takes a long time to build up the skills you need to do that sort of thing. The models are also extremely complex, and I have to run some of the models through a software program to try to remove some of the extremely fine detail that wouldn't show up anyway on a print. This particular print, you can see right down the bottom there is the same plastic, but it's used as a support for the model, and that all has to be manually removed from the model. That's also a very time-consuming and delicate process. So we do now have a dual-headed printer which can print the support material in a different material, which can save a bit of time. So that's, which one was that one, Porritt? Can you remember? That was the Ebola, wasn't it?
Yeah, that's the Ebola virus, cylindrical one.
That was just a portion of it, wasn't it? It wasn't the whole component.
Just a part of it, yeah.
Yeah.
Excellent.
Great, thanks.
Thank you, Simon. And thank you, Dr. Padraig Strapp and Simon Cumming for that one. So now we head over to Bundaberg. Dr. Benjamin Taylor, who is going to talk about CYSA, the CQUniversity Youth STEM Academy. Over to you, Dr. Benjamin Taylor. Thank you.
Thank you very much. Linda, can you hear me okay?
Yep. Yes, we
Fantastic. Can. Okay, I've just got a quick presentation to run through. So CYSA, or the CQUni Youth STEM Academy, has been running since 2018 in various forms. So basically, this program is fully funded by the federal government under the Higher Education Participation and Partnership Scheme. And it's all about trying to increase the number of low SES students who are coming into higher education, or in particular into STEM courses in our case. So the aims are, we're working mainly with the Year 9 students, and particularly trying to focus on those who come from the low SES families, which is why essentially we're based in Bundaberg, because that's where a lot of the low SES population is. We've identified that there's a bit of a void in terms of these people being able to access STEM role models. So we're trying to fill that void by creating STEM ambassadors at each of the local high schools. So that's where we select students from Year 9, and we actually pay them to be a STEM ambassador and to do some activities at their school. So we're creating these engaging activities to try and help people to learn mathematics in particular in a practical way, and at the same time we're trying to empower those future STEM leaders, building their skills and confidence. So this year, these are all of the STEM ambassadors that we've appointed at the various schools that we're working with. And unfortunately, due to COVID, we had a late start this year, but we've now got all of these students currently working on coming up with their own activity to run later this month for their peers at the school. We've got a fairly big team involved. So we've also got Shaminda and Aruna who are helping out in Bundy and Rocky, Nicole giving us support, and we've got 3 undergraduate engineering students who have just recently been appointed, and they're our STEM school liaison assistants, and they're helping out with various schools. So it's a fantastic initiative to try and get our undergrads also employed and working for the university. There's essentially 4 activities as part of the CYSA program, although with COVID we haven't been able to do everything. The first activity usually is where the students come into the engineering lab for a couple of hours and actually do a practical mathematics excursion. Then the second activity is where the school actually runs their own STEM activity, but we provide the resources for that activity to run. Then we do a bit of a research survey, and then finally, early in the next year, we bring all of our STEM ambassadors together and run a student conference where they share what activities they did in the previous year. So the practical mathematics excursion is about looking at structures, seeing how they deflect or the loads on structures based on different loads that we applied. And it's about getting the students an understanding of how their mathematics curriculum is applied in the real world. So for instance, how you can create linear equations and so forth. The in-school activities, the students dream up their own, and we spend a couple of $1,000s on each school, giving them resources to do their activity. Last year, we did some VR stuff. Students wore GoPros and did their favorite pastime and measured the acceleration on their bodies. They also did a lot of projectile motion, throwing things, measuring speed, and so forth. So you can see some really fun ways of learning mathematics. Just obviously, the conference is the big event for us, where all the students share what they did from each of the schools, and it's a way to also encourage new STEM ambassadors to come into the program. Some of the main outcomes are we've now participating with 7 schools across 3 districts. We've appointed 26 ambassadors over the last few years, which is fantastic. Each of those are getting a bursary of up to $500. We've gifted about $20,000 worth of STEM resources to the schools, and that's really good because it means that the schools can continue to use those resources. And each year we build on that, so we're starting to create a really good set of resources out there. Supporting the undergrads, as I said, we're employing undergrads, but also in the past we've had some of our undergrads co-author some of the research publications that have come out of the project as well, which is fantastic. That's pretty much it from me. Hopefully we might have made up a little bit of time there. Linda, any questions?
Ben, I have a question for you. It's Marg Flanders.
G'day, Marg. How are you?
Yeah, good. Thank you, Ben. Just how sure are you of the continued funding? What's the lifespan of that funding?
Yeah, so obviously, if in case you're not aware, HEP funding is on a 12-month cycle. So about this time each year, we apply for funding for the following year, and we just have to wait and see. So being 100% HEP funded, if we don't get the money, the program stops.
Okay, so you're not looking for industry funding then at all, or until you hit a stumbling block, really?
Yeah, at this stage, we're focusing on the low SES, and so we've got a really good niche market there. And if you look at all of the HEP projects that we're running, while many of them touch on STEM, this is the one that's centered on STEM. So, you know, we seem to be at this stage doing quite okay.
Good, good. That's excellent. Thank you.
Thank you.
Ben, I've got a quick question. It's Christy Lee Alfrey. How are you going?
Good, thanks, Christy.
Thank you for the presentation. I noticed most of the schools are state schools. Have you got any opening for private schools? Yeah,
so the reason that we've done that is because we're targeting low SES districts, and there's a map you can get. I was actually going to bring up a screenshot of the map, but I ran out of time. And it shows the, by sort of suburb or even smaller area, what the LSES percentage is. And certainly the majority of the low SES families are sending their kids to state schools. I mean, that's very stereotypical, but what we're trying to do is to go to the locations where the majority of low SES students are.
Yep.
And I should say students from low SES families, that's the correct way of referring to them. But so you go then to a private school and you're not necessarily getting the same demographic.
Yeah, not a problem. Thank you. I just have a daughter who would be incredibly enthusiastic about this. So
yeah, we've had the private schools interested, and I've simply said to them they can be involved, but we wouldn't be funding their resources. Obviously, they'd have to pay for their own.
Fair enough. Thank you.
Thank you. Great question.
Okay. Sorry, you're going to get an echo. Can you just read the chat?
Sorry, and I will unmute. Thank you, Linda. Hi, my name's Ashley. I come in with a little bit of a different view to this symposium. I'm a data science student currently studying in the area of STEM, and I want to talk a little about citizen data scientists and how we can make it more accessible to students like myself. So I don't have a strong background. I don't have years of programming or understanding how to develop predictive algorithms, which is the area that I'm highly interested in. But I want to talk to you today about how we've implemented, this is a solution implemented within CQUniversity, not as a student, but how it's opened the door for me to go and further my understanding career in data science and make me realize that, hey, just because I can't write code amazingly well doesn't leave me out of the door of this opportunity and this as a career. So I'll share my screen. So again, this is about AI in higher education and implementing solutions as citizen data scientists. So often when we talk about data science, for people like myself, it seems overwhelming, particularly when you're looking at developing an algorithm, where to start, how do I write, what code should I write in or language should I write in, and how do I get that syntax perfected? It seems like an overwhelming thing and you just have no idea where to start. But what you do have is a business knowledge and an understanding, and you do know the end goal that you're trying to get to. This is where automated AI and a lot of tools on the market come in to close that gap and make data science more accessible. At CQUniversity, we leveraged this, and I led the project for the implementation of a predictive analytic model for student success. What that meant was investing in a data science tool called Data Robot, which is one of the many data science tools on the market, and it automates the process for developing a predictive model. You build your features that you know that you go in, you test and run and scale, and it allows you to rapidly test and build solutions over and over again to get to the end product and the accuracy that you're looking for. With the model that we had about 50,000 data points going in for 19,000 enrollments each week. So it's incredibly scalable as well. And it was calculated, the data that we used was student demographic, engagement, interaction, progression, and institutional data. And I missed my notes on one of these. Here we go. Sorry, I lost my place. Technology is a key enabler in the rise of citizen data scientists. It has gotten easier for non-specialists to use, and it means that we don't have to go to market and find those specialist individuals. It is also a launching platform to bring a more collaborative approach to our design and implementation solution, so that we can have everyone at the table and not just have a select few design the approaches that we do. So it makes it more accessible, it makes it more balanced in the approach as well for the different types of people who feed into the development. Finally, I will just click to my last slide and just give you an update on the accuracy of our model. It was 87.63%, but what it did teach us is that we have a long way to go, and we can rapidly do that to look at tailored models to different segments of cohorts. So it opened up the door and the capability for us to then go down different channels in our solutions quite easily and quite quickly. And the key as well is that we were able to work with business areas to rapidly design and adapt to our solutions too. So a very quick presentation from me. And just a last thing on that, I recently just completed my first AI programming unit, and it was really difficult from a technical perspective to write the programming language, but having this background first and being able to play with these types of tools first to build my understanding of how to construct them was really key to passing that unit later on and getting and finalizing and progressing. So hopefully end of next year, I'll have my master's and I'll be speaking this to everyone else out there. So thank you.
Thank you, that was wonderful. Now we have Dr. Amanda Rebar. She's taking 2 times off. Amanda wants to talk about open science. So this is the camera they're looking at you at, right?
Hi, everybody.
Open science, and then your undergraduate research lab and the Acura conference.
Yeah, all things. Hi, everybody. Thanks. And before I jump in, because I have extra time, Ashley, I wonder, can you talk about just one quick question with your AI? What did you do what was your aim? What were you predicting with that?
Sorry, I talked too fast because I got nervous.
That's okay.
That model was specifically looking at the likelihood a student would pass a currently enrolled unit.
And so you could predict if they passed or not based on the demographics and what they put in their enrollment stuff? Is that what that was?
It was 27 features that were put in based on their demographic, their progression, and then also their engagement in the learning management system as well.
Oh, so how much they've signed into Moodle and everything.
Yes.
Wow, that's huge. That's fascinating. Well, thank you for that. And I am much less polished and prepared, but that is because I want to talk to you about what science was to me when I was getting trained and what it is now, and why I think that should be different. So I'll kind of blend all my topics into one big thing. My name is Amanda Rebar. I'm the director of the Motivation of Health Behaviors Lab, and I'm surrounded by several really ambitious and more prepared and dedicated than I am students, and several of them are here today. And I want to talk about when I went through undergrad, I studied psychology and I volunteered in a research lab. And the director of the lab was an 87-year-old man, expert in the field. He taught me to do statistics on punch cards. So instead of running, our data through an analytic program, he'd put it on punch cards, and then you'd have to go to the library and put it through a system. And it made testing hypotheses much more slow and you had to be quite thoughtful about the hypothesis you tested, because you then have to bring it to the library in a punch card and put it through, and they would then report the results, which is not how we do things now. And my training kind of from him evolved, and most of what I learned was through the graduate students in the lab and the undergraduates and the people around me and the community around me. So I learned very little from my research training from the actual professor, because science is evolving and research is evolving and the way we do it is evolving. And open science is one example of that. So, years and years ago, you'd go to the libraries, you'd get all your resources from books, work really hard in this siloed library and do it yourself, and then try to get it published in a scientific journal by sending your printed manuscript into 3 big envelopes and send it off to the journals, wait several months, and you'd hear back by post. Everything's electronic now, obviously, so that's very different. But there's a lot of other differences that I think most of our students in research courses are missing. So there's this open science revolution happening. I hate that you guys are behind me, I'm sorry. Oh good, yeah, look that way, okay. And the idea now is we shouldn't have science for only the rich. So we shouldn't have our articles published in journals that are only accessible through institutions or through people that can afford to pay for it. Why are we doing science to help populations, for example, if those populations aren't able to access the science and get the evidence that they need to make smart decisions? So there's a whole range of journals, data analysis resources, and communities with researchers that connect. And it's open science because it genuinely is much more collaborative and transparent than it was years ago. And this is kind of driven by the idea that in psychology, some of what was being found wasn't being replicated. And that's our whole aim with research, right? Is to test hypotheses and do it in a way that is replicable so that it's not just a once-off finding. And from that has stemmed this whole idea that, you know what, maybe we should be transparent all the way through from the beginning to the end. So now there's options to publish in what are called open access journals, where it's still kind of a messed up system because you have to pay to publish. But the idea is the resources, instead of asking people who want to know the evidence-based answers to pay for those, we say, okay, as the scientists or as the institutions funding the scientists, that's where the funding comes from. And then it's open to everybody. The other ideas is protocol and pre-registration papers. So for those of you that have published, the process usually goes, you do a study all on your own, you collect the data, you analyze the data all on your own, and then you write up the paper and send it off to review. And as a peer reviewer, and then it gets sent off to other academics in the field that decide if it's worthy of publication or not. And as a peer reviewer, it can get quite difficult deciding if something's worthy of publication when it's something that's wrong with a study measure, because they can't fix that now unless they collect more data. So does that mean that that bit of science should not be out in the world because there's a minor flaw with the methodology, or there's something, the wording of the measure isn't right? So now the push is to do protocol papers and pre-registrations where you publish what you're going to do, your plan, your hypotheses, your data analysis plan, and that's what gets peer reviewed up front. And you say, this is my plan, this is how we're going to answer this question. That gets peer reviewed so that those recommendations can actually be actioned. And then you go on to do the study and you're held accountable to the processes and the analysis that you put in your protocol or your pre-registration. And therefore, when you do the study, regardless of what the results are, they then have been peer reviewed already. And you might have some more peer review comments about the writing up of it or the discussion. But in general, it avoids some problems that have been occurring in science where, you know, you kind of go fishing through your data for the best story, or you don't want to publish it because your hypothesis wasn't supported. Well, if all of science does that, we're not going to move forward, right? So I think it's really important to stay up with the trends in how science as a field is going and how research is actually being implemented. And the way to do that, I have no idea what I'm doing, timing, just stopping, is through our students. It's impossible. Everyone here knows how busy they are. It's impossible not to start a meeting by saying how busy you are. I've learned this. I've been trained as an academic, and that's how I start. Super busy today, just so you, and it's true. We jump from thing to thing to thing, and you don't get the time that you used to make sure that you're up on the best way to do things and how the field is shifting. And I don't get the chances to stay caught up in that. But if you surround yourself with students who are willing and able to do that, and you give them opportunities and resources and the ability, that's where that can come through. I mean, some of these students in this lab, and these are all mostly volunteers in our lab, have caught up on, Ashley, you'll like this, the R Markdown coding, right? So there's this data analysis program called R, which is, again, open source, so everyone has access to being able to analyze data. It's code driven. So everyone's learning about code, and it's such an open community, and everyone's sharing online. I Google how to do X in R probably 16 times a day and just steal someone else's code. And it's not stealing because everyone's sharing. So some students will take that opportunity and be able to learn more than I ever could. And so I can teach them the limited stuff I know, and then they go off on these amazing opportunities and take it in ways that I couldn't, or I didn't have time for, or I never would have thought of. And this is the case not only for analyses, but for publishing. And students have taught me about pre-registration. They say, hey, can we try this protocol paper? Sure, what is it? And I learn with them. And I just think in general, we need to shift how we train research to be much more collaborative and give that chance to provide opportunities instead of just the typical system of, here's how you do things, this is because this is how I was taught it 16 years ago, so nothing has changed. Let's all pretend that the field isn't moving forward. And I just think we need a better system to make that happen. And how we've done that in our lab is through undergraduate students and sharing, having a virtual community where we meet every month. We talk about what projects we have going on and what data we're collecting, and we say who wants to take on this or who wants to go do some training and then come back and share it with everybody. And I think if science does that in general, we'll move forward so much better. Anyway.
Plug your conference?
Yeah, and so, this is one of those examples. So amazingly, we have outstanding undergraduate students who have done their own projects, and they were gonna go to the Australasia Conference for undergraduate research in Australia. We did it last year, and we were gonna do it this year. And of course, it was closed down because of COVID. So we had a little meeting because everyone had worked so hard. What are we gonna do? Well, someone in our lab just recommended, why don't we just do our own conference and do it online? And we emailed the other conference organization committee to make sure we weren't stepping on their toes, and took it over. And these students, I probably spent a total of 5 hours organizing this. Like, I did nothing. I just sat there and was like the doctor so that it looked credible. And I mean, it was the most outstanding online conference, maybe actual conference I've ever attended. It was organized well. The presentations were of a caliber beyond what you see in normal scientific conferences. And there was one moment where we had an online poster session, and all of this was hosted on the Open Science Framework, by the way. So all of the students have publishable abstracts from their presentations that they can then put on their CVs. And there was a moment where we were doing these posters, online posters, and 2 women of minority ethnicities started arguing about Bayesian statistics and the best way to fit model curves. And like, I almost cried. I was like, yes, like that is what science looks like. It's a virtual conference where these young females that have undoubtedly had to overcome barriers in their life are arguing about how to use Bayesian models to fit these different curves. And I just want to do everything I can to help support that initiative and allowing opportunities instead of just training skills.
Will that be offered again next year? Yeah,
so we're doing it next year. It's funded by the CREATE Center, as well as our lab and hopefully some others. So we had 118 attendees last year. We're hoping for more, open to all fields of science. And it opens, I think, what is it, late September, Christy Lee?
We're going to put it a little bit earlier this year coming so that it doesn't clash with a couple of other undergraduate conferences.
Smart.
So maybe early September will be the conference, and abstracts will close probably about 6 weeks before that.
And it gives amazing opportunities for undergraduates to help organize it. We had postgraduates do the judging and the abstract reviewing, and it's just that chance to get experience every time. A lot of times people at that stage of their career get turned down because they don't have experience and they don't have the know-how. And we really don't, we're the ones that are like, you need experience, that's us. Like, we can be that first line on your CV and use research to train the skills and the problem solving and the initiative that is relevant regardless of the field you're in. So there's my little rant. You're welcome.
There's my hook. Thank you. Thank you so much, Amanda. It's really inspiring. So next we're going to fly down to Brisbane, and hopefully Dr. Jay Deegan is there ready for learning and teaching in home economics education.
I am Linda. Hello, everybody. And I'm actually in Emerald. I forgot to tell you that. I moved in the beginning of the year, so I'm out.
Oh, sorry, yes, I did know that. Sorry.
That's all right. Anyone who knows me knows that once I start talking about home ec, I find it very difficult to restrain my time. So what I've actually done here today is I've put together a video that will explain it probably better than I can. Well, it's me explaining it, but can you see the video? Yes, you can. Okay, so I'm going to play my video now and give you an alternative perspective of what people may think about home economics.
Hi, I'm Dr. Jay Deegan and I'm the Senior Lecturer of Home Economics here at CQUniversity. Most people think of home economics as cooking and sewing, and they'd be right. But what I see is STEAM in action. Home economics sits within the human sciences, but we draw from multiple disciplines to make up our content areas. At the heart of home economics sits the idea of technology use and health and well-being for individuals, families and communities to achieve optimal and sustainable living. Now I'd like to show you some of the teaching and learning in home economics that happens here with my students at CQUniversity. To give our students an authentic experience, what it's really like to be in a school kitchen, we partner with schools in Brisbane and Rockhampton to teach them workplace health and safety procedures and safe use of equipment. We also look at recipe modifications and health and allergies. Our pre-service teachers use the design process to develop a new food product. They explore food security, food waste reduction, local produce, sensory evaluation, and a lot of exploration of census data. In third year, our students head into the commercial kitchens where we have a wonderful time. We look at about 30 different experiments from the 4 food molecules, including water, lipids, carbohydrates, and proteins. We look at foam formation and dextrinization and cheese appreciation, a lot of cheese appreciation. We look at processes such as weights, measures, costing, safe equipment use, and also how to make the perfect ice cream. The next area our students head into is textile technology, a very strong contender for a STEAM subject. We look at manipulation of textile materials. We play with a lot of textiles. We do wearable technology. We look at how to safely use things like the sewing machine. The sewing machine was one of the first pieces of technology used. And quite frankly, without people knowing how to use a sewing machine, we'd all be naked. The final STEAM subject that our students do is fashion design. Here's some photographs of my students displaying their proud work. They had to manipulate either an existing pattern or create their own pattern, fully tailored outfits that fit them. They use projects such as Adobe Spark and Adobe Photoshop. They also do pattern design, pattern manipulation, modifications, and importantly, they learn how to use an iron properly. This final student is Glenn. He now has his own fashion label called That Dad That Sews. To see students find their passion for fashion in this subject is a wonderful experience, and anyone who has ever made anything with a sewing machine knows that it is full of maths and technology. Where you might see cooking and sewing, a home economics teacher understands that their students are participating in a STEAM subject. Science, technology, engineering, arts and maths are embedded into all of the hands-on activities that we do. This informal learning in the middle years and senior years is really important. Home economics is STEAM powered. Thank you for watching.
Yes, so there you go. That's in a world of experts, the home economics subjects provide us with the entry-level generalists, which then can expand out into all sorts of different industries. Two of the places that I know home economists are one is Dr. Margaret Chan, who started out with a degree in home economics teaching, and she ended up to be the head of the World Health Organization and specialized in pandemics. Another one is the NASA program also has home economists because they understand that how to make the space environment and NASA more home-like. So all of that technology, all of that science that goes into understanding the home is another area. And they also need to sew the astronauts' spacesuits. So in terms of careers, this home economics in the middle school and senior school, particularly the middle school, is a way for students to be informally introduced to all of the science, technology, engineering and maths. And also we have the added advantage of being a creative and artistic area of middle school learning. So that's what we do. Thank you very much.
Thank you, Jay. That was amazing. That was awesome. Thank you. A lot of entrepreneurialism in there too, and innovation, which I say innovation and entrepreneurship seems to be the new STEM. The STEM was, you know, it's a bit old now. So yeah, that was a wonderful presentation. Thank you. Also, Science Week theme for next year is Foods of the Future. So, you know, a lot of things to do there. Thank you so much, Jay. Next, we have Kim Waters, a student online at Mackay with Take Your Grid Positions, Human-Powered Vehicle Racing.
Can you see my screen there?
It's not on, is that it? Yeah.
Okay, is that better? Excellent. All right, so I didn't know what HPV was. There was an event here in October in Mackay, so I volunteered as a CQUniversity student at this event. So I'm going to talk about my first time HPV racing experience. So last year, STEM Challenge teams competed in an 18-hour race competition. However, due to COVID this year, the Whitsunday STEM Challenge incorporated a new race format, and that was hot laps. So each lap was 985 metres long, and it happened over 8 hours at the Palmyra Dragway in Mackay. So we had school students that came together to race in a safe, controlled environment. We had 14 teams. Each team was 4 to 8 riders in a team and 2 pit crew. And we had teams that came all the way from Bundaberg. So students use their STEM skills, they design and construct their vehicle, and we have a scrutinising process before the race, and that determines if the vehicle complies with the current standards and specifications. So these vehicles, they're a 3-wheeled, individually operated, fully enclosed vehicle with a single seat position inclined backwards with the pedals attached to the front. So most of the vehicles weighed around or under 10 kilos, although they do look heavier than that. All the vehicles are designed to contain the driver in a safe, strong, yet tough enclosure, and that prevents the driver from coming into contact with the road, obstacles and other vehicles as well. The students also are fitted with approved bicycle helmets. They have shatterproof eyewear, gloves and cleat shoes. And they lock into pedal toe clips to prevent their feet from coming loose and off the pedals while they're pedaling. So the world record held by the Dutch students clocked at just over 133 kilometres per hour. And although the expected speeds over this weekend were around the 70 kilometres per hour, the vehicles were powered by muscular strength. They reached an average speed of just over 40 kilometres an hour. So just to set the scene, each team had a gazebo, and the ones that came from Bundaberg had a big row of gazebos and a really massive bus. So they had warm-up bikes, they had toolbox, which was a mechanic would be absolutely in awe of. It was like so high, it was incredible. The camaraderie and the cheering of all the teams. So it didn't matter what the team was positioned throughout the race. They were inclusively and positively supported by their schools, their teachers, the parents and fellow students. I was really intrigued by the mechanic crews. So these were students on a little tiny push bike, and they would reach a vehicle from anywhere over the course in quick time to get their team's vehicle back on the track. So the job of these student mechanics, they tended to flat tires, they put chains back on, and they righted the vehicle after there was a rollover. So we had a couple of accidents and students did require medical attention. And there was one student in particular who came back from where the accident actually was. And she's like, "Don't go down there, it's a bloodbath." So, and another student was taken to hospital and he had a broken ankle. And he returned back to the event on crutches and was zooming around cheering his team on. They were just so dedicated. So this was a great day for a HPV event being held in your area. I suggest go along and see what it's all about. I did, and I'm going again next year. Thank you.
Thank you, Kim. That's really great. We do, the HPV, it does run around Queensland. I know that I got CQ to sponsor a vehicle at my children's school. So you should hit up your Associate Vice President. So they've sponsored a vehicle for Tenham Sands State High School. It's a great event and it does run all around the state. So well done. Thank you, Kim. Next, we have Anna Ray, who is another student online in Cairns with Diets for the Future of Global Health and Climate Change.
All right, good morning, everyone. I'm Anna, and I'm an undergraduate student studying a Bachelor of Medical Science majoring in nutrition. So climate change might not be the first thing that comes to mind when you think about nutrition, but there is an inextricable link between diets and the environment. So to put it simply, we know our food systems produce food and that contributes to our health. And this requires the use of finite resources such as land and water, produces waste such as carbon emissions and livestock wastes, and this both impacts ecological stability. Just a moment, I'll see if I can get my cursor up. Laser pointer, awesome. So where was I? So in fact, the agriculture, forestry and land use contributes to 24% of global carbon emissions. And this is just behind the electricity sector at 25% here. And our food systems are both a contributor to climate change here and also are vulnerable to the effects of climate change. And this multiplies the risk of global health risks. Oh, doesn't want to change slides. There we go. So the reduction in both the quantity and nutritional quality of our food supply is referred to as food insecurity. And undernutrition and malnutrition have been anticipated to be prominent health risks associated with climate change. But the health implications extend beyond dietary health. So increased air pollution contributes to cardiovascular and respiratory conditions, and this exacerbates current health challenges worldwide. And ecological changes can create hospital environments for vectors to transmit diseases, so things like mosquitoes transmitting malaria, but also flooding increases the transmission of waterborne diseases. And because this is an input to food production, it compromises our food safety. And these are only a few examples of why climate change have been described by the World Health Organization as a global health concern. So if we return back to this interrelationship between climate change, health, and food, food can actually be a central component in climate and health strategy. There are many other contributing factors here, but our food drivers can actually be a key a driver to influence global health and climate change. So what we put on our plates not only influences our health, but also contributes to global health and climate change. So how do we know what to choose? So the most recent Australian Dietary Guidelines and Guide to Healthy Eating was published in 2013. And at the time, there was insufficient evidence to support specific dietary recommendations associated with the environmental impact. But it was also suggested that following the Australian dietary recommendations and guides had a lower environmental impact in comparison to most Western diets. So in 2019, the Eat Lancet Commission established a dietary guideline that meets our nutrient requirements and can be produced within the boundaries that preserve ecological stability. So the notable difference here between the recommendations are the increase in vegetable intake from 1/3 to half of our diet on a proportion of our plates. And they also distinguish between animal and plant source proteins. And there is a large body of evidence that indicates a shift towards a more plant-centered diet, which has co-benefits for population health and planetary health. So diets rich in, diets rich in whole and unprocessed foods So things like whole grains, legumes, fruits and vegetables, and nuts and seeds have co-benefits for population health and planetary health. And so they're protective against chronic conditions and that are our major contributors to morbidity and mortality today. So nutrition is a preventive health strategy, and we should consider climate change as a global health risk. And as nature would have it, the same foods that are health promoting also protect our environment. And more plant-centered diets can be an investment into our future, affecting our health, our families, our communities, and beyond. So choose wisely. Thank you.
Thank you. That was great. Thank you. It's great to see so many students here, Amanda. That was a great presentation. Thank you very much. Next, I have Desley Pigeon on the schedule, but I don't think Desley's with us today. I think she's away. So we will head to Mina online in Sydney with WinTech. Mina, are you ready to go there in Sydney with your women tech?
Yeah.
Excellent.
Thank you, Linda. Allow me to, and thanks everyone. Allow me to share my screen first. Can you see my screen?
Yes, I can see your screen.
Okay. Sorry. All right, thank you. I'm Meena from Sydney campus, and I'm going to talk about my WinTech, that is Women in Technology, which is a registered society within CQUniversity. What we do is, it is all about inspire, support, and empower women. So Women in Tech STEM Club aims to build a community that provides encouragement, support, and holistic development to empower students through various activities like workshops, fun events, virtual meetups, webinars with women who are already successful in their STEM careers, alumni panel sessions, workshop tours, and much more. What we actually do is we run workshop for high school and primary school students in STEM education, and we run workshop for high school and primary school teachers in STEM education. We are also running mentoring programs, and we have got almost 27 mentors working with us on this mentoring program. We actually invite parents to be part of this workshop so that they actually understand the problems associated with STEM and gender inequality. My STEM education is about addressing gender inequality in STEM education. So we are collaborating with other universities, University of Newcastle, UNSW, and Macquarie University, and non-profit organizations like Real Skill People, who are actually coming and delivering these workshops and mentoring programs. We have reached 7 high schools, 3 primary, with 35 students mentored and 15 teachers working together with us. So according to UNESCO report, it is only 35% of STEM students in higher education globally are women, and differences are surely observed in STEM discipline. So when we are talking about high school and we are running these workshops, it is this career progression pipeline we are trying to address. That this has come from STEM, Women in STEM Decadal Plan, Australian Academy of Technology and Engineering 2019, and we are trying to address the lack of role models by supporting them and providing the mentors to the high school and primary school students, and family cultural expectations. And that is the reason we are inviting parents to be part of these workshops. The stereotypes, why, women can't do this, why is that so? these are some of the photographs from what we run. This year, last month on 3rd of October, we ran a workshop on data science, exploring data science, and we had almost 45 people joining us on that workshop. So it is empower yourself and others, personal development, professional development, mentoring, support, alumni, career journey, and we have got social media page. You can go and see that we have posted many things over there. The idea behind it is when we are inviting role models, people, students, actually high school students, get to see them, get to talk to them, get to speak, and they can actually connect with them and, progress onto their STEM careers. So if you want to be, it is a very short and sweet presentation. If you want to come and join us in your, join us on this journey, and you can give us, email us wintech@cqu.edu.au. That's all from me, Linda. Thank you. Thanks, guys. Any questions?
Thank you, Meena. You had some comments in the chat there, I think, some volunteers.
Oh, I would love to. Yes, and on the, we have been actually running workshops for primary school students, actually how to develop their own website, and it was really thrilling to see that when they were coming up with their own ideas to develop websites and all. And we actually also ran a workshop on Python and R for primary school students. We are making them how open source. Yes, and that is really, really interesting. They were taking a few codes from Microsoft Excel. They were taking it into R and Python, and they could see that visual presentation. That was really amazing. Thanks. Thank you. Yes.
Thank you, Meena. So I'm last, so I'll be really quick. Hopefully you can all hear me. I'm trying to do the sound on a different device to the picture. But I wanted to talk to you about the STEM leadership team that we have at CQUniversity. So we have a STEM leadership team that developed a STEM strategy that is online somewhere on our website. And we've tried to have representatives from different schools and divisions and different campuses, as well as student representatives. So I'd also like to thank this leadership team for pulling this today's symposium together. And we have a student, Kate, sitting over here in ATIC helping me with the technology as well. So thanks, Kate, for coming in as well, and for the students that are presenting today. So that's really good. The role of the STEM leadership team was to start a STEM strategy. That was our first role. We did that. We launched it last year. At the beginning of this year, we were going to announce that we have a STEM leadership team and who they are and what their roles are, but COVID came and we didn't meet for most of the year. When we got back together, the directive from the provost was, I asked what sort of focus could we have for this team. We need, something to do, I guess, how we can move forward, and that was to try and utilise ATIC, which is where we're sitting here today. The Advanced Technology and Innovation Centre was one thing, so we decided we would try and do a symposium really quickly, and we have. So that's really good. We have goals in the STEM strategy, which is probably a lot of what we've been talking about today, to work collaboratively, to look at how STEM and STEAM, whatever you want to argue, a coordinated approach across learning and teaching, research, engagement, social innovation, all of those areas. And we are looking at creating some sort of website or online platform. The other thing I wanted to talk briefly about is STEM Central. So STEM Central is a room at Gladstone campus similar to ATIC. So ATIC is a room here. Upstairs has been modelled on STEM Central in Gladstone. It has different coloured zones as well. This project it's actually up to $700,000 now through Australia Pacific LNG. And these are just some photos. So the picture on the left is the artist's impression, and the picture on the right is the actual photo I took inside the room. So it's quite impressive when I saw the design, and when I walk in it's very surreal. It's got 7 zones. STEM Central has 7 zones. We have a little booth, we have a dark room so we can do light experiments, VR. We have what's called a coding lab, that's where we fly the drones. And some of the activities we do things with playgroups, primary and secondary schools, teachers, seniors, Indigenous groups, linking agencies, people with a disability, mental health, a lot of environmental stuff because we're in Gladstone. And we have a lot of activities, GovHack, First Lego League, Tech Girls, Science Experience. We have built a relationship with Questacon, CSIRO, the Queensland Virtual STEM Academy, etc. But that's basically my really quick presentation of what I do. Are there any questions we might open it up to a quick Q&A. I'm conscious of the time. I'm sure everyone's very busy. Aren't we all busy, Amanda? We're all busy. If anyone would like to open up for some questions for any of the presenters, I really would keen to hear from Jay as well. When you were talking about using the sewing machine and the iron, I laughed because my son irons now, but there's a big push for the lost trades. There's a whole organisation, I think they're in Melbourne, and they're really pushing for those skills. They're calling them STEM skills, but STEM. And, you know, those 21st century skills, those old skills from the lost trades are being lost. So now we're having people not being able to fill, you know, those jobs where the technologies have changed or they don't have the skills back there. But any questions for any of the presenters? Please just unmute and, yeah, ask away.
Linda, it's Jay here. I will address that issue of, I think that this pandemic has really demonstrated a lack of general home-based skills, and subjects like home economics in schools. And don't forget, I know that in Australia, home ec is usually just a school subject, but home economics in the whole world is very localized to their context. So, but it all still sits around health and well-being, use of technology in the home. And I think that the face mask sewing with the pandemic and how to make, you know, soda bread and how to keep your bugs alive. So home economics, I just want to let everybody know that it is actually a very, very strong subject and compulsory in many countries in the world. And where they've taken home ec out, they've realised their mistake and put it back. So hopefully we'll start that groundswell here in Australia. So as understanding that home ec is a place where all of the other subjects and passions and jobs, especially sewing machine repairists, we have so few, is a place to inspire many different career paths, but it's also about just living. So that's my...
Yeah, thank you, Jay. That's excellent. Thank you. Does anyone else have anything they would like to add?
Hey Linda, it's Ben here. If I can just quickly reiterate a point that we spoke about some time ago. There's so many STEM things happening, or STEAM, or whatever you want to call it, and I think that's fantastic. But perhaps what we don't have is a bit of an overview of who's doing what with who, you know, because we're all working with different year levels and sort of different programs at different times and so on. It would be really good, I think, if the STEM leadership group could actually manage some sort of a map that had something there that we knew what was happening on each campus within each of the schools, so that we could identify perhaps areas that are a bit saturated and other areas that we're missing out on. I think it would become a really good strategic tool. And if it's something that we can all share and have access to, then we can actually use that in planning our own STEM projects to try and fill those gaps.
Yeah, thanks, Ben. That's a really good point. So I think obviously we do need to map that out. We do need to see what's on each campus and each school, including equipment, what's sitting in cupboards and not being used, which target market areas we're looking at, and also our programs. Instead of 20 people running a program for Year 9 kids to come through, you know, we could share those resources. I'm hoping that this ATIC Centre that's just opened last month that we're sitting in, the Advanced Technology Innovation Centre, STEM Central in Gladstone, the Makerspace in Bundaberg, you've got an Ag Tech Centre in Bundaberg, you've got Mackay's got, I can't remember what it's called, you've got something on the campus there, plus all our research in Rockhampton obviously has a lot of things. You know, Cairns has got the aviation, Townsville's got a Emergency Response Innovation Centre. Like, we've got big things on every campus in our footprint, and to try and have that centrally I don't know, accessible, I guess. And as you said, there are places that are saturated, academics are busy, can't do engagement all the time, people are researching, they want to reach out to and work with other people. So I agree that should be the next focus of the STEM leadership group, is trying to map out what we have and how we can, how we can work together, but putting that somewhere where we can find it, where we can all have access to it. So yeah, I'll take that feedback on. Thank you. Does anyone else have anything they would like to add? Yes?
So are you as an organisation in CQ able to fund projects in charity?
We don't have any money. We don't, the STEM leadership team of the people have just given up their time, so it's not even a workload allocated group. However, there are lots of grants around, and if people work together, I think there's a lot of industry support. I don't know, I know Mina gets lots of grants, Ben, you know, get funding. I've got industry funding. There are grants around if we worked together as a university. But as a STEM leadership group, it's just a group of academics and students who are giving up their time. We meet once a month and try and get what we can done. So there's no actual funding for projects, but if you had a project and you knew, once we had a map and you picked out some people, then you could also pick out some possible funding opportunities, because there's a lot of money around, yeah, for different things. Does anyone else have any? I'd love to have a budget. Anything else? All right, well, we might leave it there then. I'd like to, again, thank everyone for giving up their time. Thank the STEM leadership team for, you know, we weren't going to do it because we're all so busy, but we just thought we'll just do it. It's not that hard. It's an online, it's a first step forward to seeing who's around doing what, because I didn't know probably half the presenters were doing what they're doing. So thank you all very much, and we'll be in touch, and I'll share the recording. So thank you all very much, and I'll talk to you soon. Bye.
Thanks, Linda. Thanks for organizing it.
Well.